All right, let's dive into one of the most powerful and honestly most misunderstood forces in the entire universe, radioactivity.
I mean, think about it. What is this thing that can power our sun, help doctors see inside our bodies, but at the same time be dangerous for literally thousands of years? It's got this incredible duality. It can be a savior and a destroyer. To really understand that, we got to go back to the very beginning.
So to get a handle on this, we have to rewind the clock to a time when scientists just stumbled upon something. They couldn't see it, but its effects, whoa, they were impossible to ignore. So at its core, radioactivity is basically nature's way of chilling out. Just picture an atom's nucleus, its core, being wound up way too tight. It's unstable, it's got all this extra energy. To get stable, it has to let go of some of that energy, and it does that by shooting out these tiny particles. That release of energy is radioactivity. It's that simple. This whole story really kicks off back in 1896 with a scientist named Henri Becquerel. He was studying uranium salts and he found, completely by accident, that they were giving off some kind of strange, invisible ray that could go through stuff. This was not supposed to happen. It totally shattered the rules of physics at the time and basically created a whole new branch of science. So you might be wondering, if it's invisible, how in the world did they know it was there? Well, it was all about the weird footprints it left behind. It could mess up photographic plates that were sealed in total darkness. It could make the air around it literally electric. It could even pass right through solid objects. It was like a ghost that was leaving very, very real clues. And what scientists figured out pretty quickly was that this radioactivity wasn't just one thing. Nope, it was more like a family of different emissions, and each one had its own unique personality and its own level of strength. Okay, so you've got three main players here: alpha, beta, and gamma. Think of alpha particles as the big, heavy brutes of the group. They're so big, you can literally stop them with a single sheet of paper. Then you have beta particles. They're more like speedy little electrons. You'd need a sheet of aluminum to stop them. And then there are gamma rays. They're not even particles, they're pure energy, and they're so powerful you need thick lead or a whole lot of concrete to even slow them down. And all this power, in all its different forms, it really presents us with a fundamental choice. It's this incredible tool for creation, but it's also a force of potential destruction. It is, without a doubt, a double-edged sword. And this right here is the central dilemma of radioactivity. If you just let it run wild, its power is a massive threat to living things. But if we can learn to control it, that very same power becomes one of our most amazing tools. Let's talk about the scary side first, the peril. When radiation zips through your body, it's like a storm of microscopic bullets just tearing through the delicate machinery of your cells and your DNA. That damage is what causes all the things we fear, from cancer-causing mutations to really nasty burns. But, and this is a huge but, we've figured out how to flip that script. We've learned how to aim that destructive power and turn it into a force for good. In medicine, we use it for things like X-rays and to target and destroy cancer cells. We use it to generate clean nuclear energy. We even use it to figure out how old ancient artifacts are, which lets us literally read the history of our own planet. But with all this great power comes, you guessed it, great responsibility. Using the atom for all these incredible things leaves behind a byproduct, radioactive waste. And figuring out what to do with that stuff is one of the biggest scientific challenges we face today. Now, we're not talking about a problem for our generation, or even the next one. The waste we're creating right now will stay dangerous for thousands and thousands of years. It'll outlast any building we construct, any government, any language we speak. We're having to think in terms of deep time, trying to create warnings for a future we can't even begin to imagine. So, what do we actually do? Well, the current game plan is basically a defense in layers. First, the waste gets locked up inside these super tough steel and cement barrels. Second, those barrels are buried deep, deep underground in facilities designed just for them. And third, the spots we choose for these facilities are incredibly stable, geologically speaking, places that haven't changed in millions of years and probably won't for millions more. It's all about containment. So we're left with this constant balancing act. This invisible force has completely reshaped our world. It offers us these mind-blowing solutions, but also these enormous challenges. And how we choose to walk that tightrope between its promise and its peril, well, that's a choice that's going to echo for a very, very long time.